Hi, this is Laura again with the McDougall-Little Geometry Textbook, Chapter 10. Here we are at 10.5, Segment Lengths in Circles. Let's jump right in here with the theorem. Now remember that math is all about patterns and connections, and so some of these things are, or some of these theorems, I should say, that we're going to talk about in this video are very similar, so you have to really pay attention. There are different rules to remember. This one says if two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments in the other chord. Now the concept of this is very simple. It just sounds very wordy. All it says is this chord right here and this chord right here, even though they may have two lengths, as in they're cut in pieces, and this length is 3 and this is 8, or this length is 4 and this is 6. So even if they are split or they intersect there, in order to find out any missing lengths, then all you have to do is remember that if you take each one, this one is 4 and 6, so 6 times 4, and 3 times 8, these lengths will be equal. So if we have 3 times 8, it's 24, and 6 times 4 is 24. Ta-da! So if we were missing one of these, we would easily be able to find it. And you can do that right now. Very simple. Pause the video, check it yourself. It shouldn't take but a moment. Okay, here comes the answer. It is as simple. This is one chord, so 6 times 3 equals 9 times x, or 9x. So 18 equals 9x, divide by 9, and x equals 2. So the missing length right here is 2. Very simple. What else? Now, remember before when we had definitions that said a tangent is a line that touches the circle at one point, and then there were some problems where they showed that, wait a minute, that's not a line. And now, later in the chapter, they start talking about a tangent segment, or an external secant segment, or a secant segment. So these are the ones where the definition at the beginning said that they were lines. Well, now we're talking about segments. So this segment is tangent at point S, and this external, we have a whole secant of PR. That's the secant segment. And this is the external part of it. PQ is the external part of the secant segment, which is hard to say, secant segment. So there you have some new terms there. How about if we use them? Here's a theorem. If two secant segments share the same endpoint outside a circle, then the product of the length of one secant segment and the length of its external segment equals the product of the length of the other secant segment and the length of its external segment. Oh my goodness, that whole thing sounds like a tongue twister. All it's saying here is that if you, just like with the one that crosses inside, that intersects inside the circle, here all you have to do is say EA times EB. Now be careful, the tricky part is it's not EA times AB, it's EA times all. So it's the portion, the external segment, times the whole segment. And the same here, equals the portion EC times the whole segment ED. It's not CD or AB. It's the whole secant. So that should be easy to do as long as you remember that one little thing, that it's going to be the portion times the whole equals the portion times the whole. Okay, let's use it. Moving on. Find the value of x given what you just learned. Go ahead and pause now. Okay, here comes the answer. This is all very simple math, so you should do this very easily. So we've got the portion times the whole, so it's going to be 9 times 9 plus 11 should equal the portion 10 times the whole, which is 10 plus x. Go ahead and do the math for that, simple algebra, and you should end up with the missing portion being 8. X equals 8. Make sure that, if necessary, if you got it wrong, always double check your math, especially when you have to distribute. Moving on. Another theorem, another rule. If a secant segment and a tangent segment share an endpoint outside a circle, over here, then the product of the length of the secant segment and the length of its external segment equals the square of the length of the tangent segment. Okay, again, a lot of words. All they're saying is the short segment is, you square it, and that should equal EC times ED. Again, remember, it's not just the portion inside, it's the part times the whole. Should equal the small one squared. Let's give that one a try. Now this may look complicated, but it's not. You are standing at point C, about 8 feet from a circular aquarium tank. The distances from you to a point of tangency on the tank is about 20 feet. Estimate the radius of the tank. So you're looking for just the radius. You want R. Pause the video, try and figure that out, given the rule or the theorem that we just learned. Pause now. Okay, right before I show you the whole answer, I want to do a little reminder that if you need this whole distance, you have an R and an R, which will give you 2R. Pause now if you want to give it another try, or here comes the answer. All right, if this needs to be R and 8, then we end up with 2R plus 8 being this whole distance. So we know that 20 squared has to equal 8 times R plus 8, or 2R plus 8. And that's what we have right down here. So if we do the math, we should end up with R equaling 21. So the radius of this circle, of this tank, is 21, whoa, what did I miss? Feet. You gotta add the feet. You gotta have the dimensions on there if it's a word problem. There you go, 21 feet. Let's move on. More fun and games. Here's another example. Find the value of x. This one should be more simple for you because there's not so many words. Go ahead and pause now. Here comes the answer. Okay, we know that it's got to be this, the short one squared, equals the partial times the whole. So the partial is x, the whole is 4x. So we simply put in 5 squared equals x times 4 plus x. We do the math. We make sure that we distribute properly. Our biggest problem here is that we get to this point where we have an x squared. Oh no. So we look and see if we can factor it. Is there any factors of 5 that will equal a 4? No. And that's always disheartening because that means we have to use the quadratic formula. Now, I went ahead and put this in, but you should be able to do this without me going through every step to get this answer. Sometimes we get some nice answers, and sometimes they get a little bit complicated, and this is one of the more complicated answers. But you can still find, when you do this, now you have to remember that we're looking at a length here, and length is always positive, so we will not do -2 minus square root of 29. We will only do the positive, and we will end up with 3.39. Moving on. Ooh, we are at the end. This was a short segment, and we love those, don't we? Now, here's the quick quiz. The hard part is remembering all the different theorems or rules of circles and tangents and segments and chords and all these other things. So if you see similar drawings, can you remember how to solve each one of these? Number one, if they cross inside, what do? You multiply AE times EB equals EC times ED. You have to remember that in this case, it's not times the whole, it's just each partial segment. That's inside when it's internal. When it's external, then it changes a little bit. That's when we do the partial times the whole, and we end up with EA times EB equals EC times ED. And then the last one is the tricky one because there is no, this is just tangent. It is not a secant here. It is tangent. So it's going to be EA squared and partial times the whole. So it's EA squared times equals EC times ED. Okay, these would be a good thing to have in some notes. As you learn all these theorems, it would be good to have a brief description of what each one is, and maybe a formula or an equation so that you could use them easily later on. All right, my friends, next time we are going to talk about equations of circles, which I really think are fun. That'll be section 10.6. Have a great day.